Number 4, find the equation of the tangent to the curve which is parallel to the line. So parallel here means the gradient of the tangent for this curve has the same value as the gradient of this line. So first we find the gradient of the tangent of this curve. So y equals to x cubed minus 11x. The gradient of the tangent is dy dx equals to 3x squared minus 11. This has the same value as the gradient of this. What is the gradient of this? So if you compare this to y equals to mx plus c, the gradient of the graph is the value 1. So m is 1. So if they are parallel means this is equals to this. So 3x squared minus 11 equals to 1. 2 or negative 2. This is a coordinate of the value of x, but since we want to find the equation of the tangent, so we also need to find the value of y and the c. So in order to find the value of y, we substitute 2 and negative 2 into this equation. We will get y equals to, when x is 2, this is 8 minus 22. You get negative 14. So y equals to negative 14. When x is negative 2, this is negative 8 plus 22, which is positive 14. So there are 2 points. One is 2, negative 14. The other point, the other coordinates, the other points is negative 2, 14. To find the equation of the tangent, we need to use these 2 points to find y equals to x minus 12. This is the first equation. And then for negative 2, 14, according to this, we get 14. I think I made a mistake here. This is positive 2. So this is supposed to be negative 16. So this is negative 16. And this is 16 here. So y equals to x plus 16. The second equation. Now we go to question number 6. Find the equation of the normal to the curve y equals to x minus 2 over 2x plus 1 at a point 2, 0. So now we're looking for the equation of the normal. So before we find the normal, we need to find the gradient of the tangent. So we try to differentiate this. The gradient of the tangent equals to dy dx. So y equals to x minus 2, 2x plus 1. We let u equals to x minus 2, v equals to 2x plus 1. So du dx equals to 1, dv dx equals to 2. In order to find dv dx, I need to use the formula v du dx minus u dv dx over v squared. V is 2x plus 1. So this is the gradient of the tangent for the curve. So at point 2, 0, x has a value of 2. So dy dx equals to 5. To find the gradient of the normal, we have to use m1, m2 equals to negative 1. So m1, I take the gradient of the tangent. m2 will be the gradient of the normal, which is m2 equals to negative 1. So m2 equals to negative 5. So we use this gradient, this value here, and the point here. We can find the equation of a normal by using y equals to mx plus c. y equals to negative 5x plus 10. This is the equation of the normal. Last question. Find the equation of the normal to the curve at the point where the curve crosses the x-axis. So since we want to find the equation of normal, we need to find the gradient of the tangent, which is using to make it simple. Actually, the equation here is the same, so I just skip the differentiation part to get dy dx equals to this as a previous question. So you have 2x plus 1 squared. So this is the gradient of the tangent for this curve. But to find the value, we need to find the value of x. So it says here at the point where the curve crosses the x-axis. So when the curve crosses or intersects the x-axis, this gives us the information that y equals to 0. But we cannot use y equals to 0 in this. So we have to use this value, substitute into this equation to find the value of x, and then we take the value of x to find the value of the gradient of a function. So when y equals to 0, according to this equation, x minus 2, 2x plus 1, meaning that x minus 2 equals to 0, x equals to 2. So we get this value, we substitute into this, you get dy dx equals to 5. This is the gradient of the tangent. To find the equation of a normal, again, we need to use the formula negative 1. So you get 1 over 5, which is similar to the previous question. So y equals to mx plus c, where y is 0, m is negative 5, x is 2 plus c, and then c equals to 10. So y equals to negative 5x plus 10. That's all. Thank you.